facts. So yes, today Elon Musk made all of our hearts pitter patter with the launch of that amazing Falcon Heavy with a central core and two side boosters, which came in like amazing. I don't even know the right words. Synchronized spacecraft. That's what they were. And it was crazy. Space kooky. Also, fish makes fish sounds. I need more words. Oh, you're hearing my tea kettle. My tea kettle is working to do the making tea kind of thing because my office is really cold, and so it didn't boil before I put the show live. Sorry about the tea kettle making the tea kettle-y noises. But yes, today, Elon Musk, there were something like 2 million people watching YouTube. Kudos to Google for keeping that stream up. There have been so many different times in the past when NASA TV has gone down, and I don't know what was done to keep that feed up, but it was amazing. And I don't know really what to say. I'm seeing links where it say that he missed it. My husband missed it too, and I made him go back and watch the video. So links work. I can't make you do anything, but I can strongly encourage you. Go back, watch the video. So I can't top that. It doesn't get better than that until the BFR rocket is ready to go. And in the press conference following today's launch, Elon Musk said that they are going to launch development at version 5, block 5 of both the Falcon 9s and the central core of the Falcon Heavy. They're locking in on Dragon Capsule with Dragon Capsule version 2. And they're going to be doing tests with Dragon Capsule, but in terms of all of their development, all of their RNA, everything is full ahead on developing the BFR, which is going to be the kind of rocket that you could just like take one of the Keck's 8-meter telescopes, stick it inside, and just launch it. And so if they're able to get that going, and he's saying that perhaps next year we'll be able to watch it doing practice, lift off, hover, and come back down. If he pulls that off, it's going to be a whole new day in space. Yeah, it's kind of amazing. And Space Cookie, I understand both ESA and Space Launch Systems here in the United States are both not going the reusable route. And I'm really wondering what's going to happen in the future now that Elon Musk is showing how much cheaper it is. It's weird. I don't know what to say other than a whole lot of ums. Fenmel's like, dual landings, freaking awesome. I agree. There were like expletives of joy that came out of my mouth when I saw that happen. It was a truly amazing day, and I think we can all be proud of what humanity is capable of doing when we show we have the will. And what happened today was someone who had the initiative and who had the budgetary authority, Elon Musk with his own company, said, we are going to do something extraordinary, and we're going to insert laughter, and we're going to make that happen. And I think that may be the most inspirational thing I have seen in my professional career. And I think the lesson for me that came out of that was dare mighty things. That was the phrase that was used with the Curiosity rover when it landed, dare mighty things. but find ways to laugh is what Elon Musk added. I have very mixed emotions about sending a Tesla Roadster up the way he did, but dang, it looked good. I am much more a fan of the block of cheese that flew on the Dragon capsule and was then eaten. But he bought that rocket himself. So it's okay. It's okay. Anyways, the reason I am here is not to wax rambling and potentially, but probably not poetic about the Falcon Heavy. Rather, I'm here to talk about Cepheid variable stars. I just don't know how I could avoid talking about the Falcon Heavy, as it was such a cool day. R2 Robot puts it so well. He's like, today was so, or she, I don't know your gender. The human R2 Robot, which is also an assumption, is like, today was so fun. And yes, it was so fun. So I'm going to go ahead and I'm going to switch over to begin programming. And I'm going to, before I give you the zoomed in shot, I'm going to show you what I did to my desktop today. All of those, and I don't know why there's a mysterious black box. Aha, it's a movable, draggable black box. I shall get rid of the black box. So everything that you're seeing right now on my screen, all of those different things are the screen captures I took of today's launch. I was sitting on my Mac watching it full screen and I was like, curly thing shift 4, curly thing shift 4, taking screen capture after screen capture after screen capture. So yeah, I may have a problem. It's a good problem. So I hope you found your own ways to capture today. But for what I'm going to work on, I can actually zoom in a little bit better. I can make things work a little bit better, and hopefully you will enjoy it a little bit better this way. So yeah, there's our Falcon Heavy escaping my field of view. Instead, what I'm going to do now is work on a variable star simulator. Now, the language that I'm using is called processing. This is a bastardized version of Java that is put out by the 501c3 processing team, and it is slowly opening up on my computer, and you will have something to see once this thing finishes opening. Slowly go the processors. So for those of you who are new and have no idea what you have stumbled into, my name is Dr. Pamela Gay. When I am not waxing on and on about Falcon Heavy, I am the principal investigator of a project called CosmoQuest. We're a multi-institutional collaboration led out of the Astronomical Society of the Pacific, which is where I work. And we're here to help you learn new ways to learn and do science. And we do this in a lot of different formats, between just teaching you everyday facts, figures, stuff, information, to sometimes we're teaching you how to code. I come in on Tuesdays and do visualizations like this. Big Joe, who's one of our coders, or Big J, who's Joe in real life, is one of our coders. And he's going to be on Monday nights and Fenmill. Yes, all of the extension cords are Eddie proofed, and I need to grab my hot tea now. Sorry, my tea kettle was going to keep reboiling the water until I grabbed the water. So Big J is going to be here Monday nights, I think starting next week, teaching Python. We have Wednesdays and Fridays. Matt Richardson is here teaching various concepts in astronomy. And Sundays are all about how to set up, use, configure CCD instruments. We are hoping to eventually add on a astronomy hands-on projects talk show that will be coming in April called Learning Space. And in addition to that, we're going to be adding in another streamer. Her name's Annie. She's going to be doing animations and showing you how to do all sorts of cool space-related animations, like the opening that we had. If you don't know our opening, this is our opening. This was done by Annie, who goes by Film Melodic on most social medias. And this is about my favorite random thing we've ever produced. And she's currently working on a new video to teach you about how to mark craters and why it is that we are mapping out other worlds. And so it's almost over. That zippy, kind of crazy rocket that you saw was inspired by a super snowy day in Ohio that Annie experienced on the day that she set all of this up. So she's going to be coming on and teaching you that. And we don't quite need a flying car yet. But yeah, we do a lot of different things, and we invite you to join us for all of them. So what I am going to be working on tonight is, as I said, programming. So this is my code window, and when I press play, it should, wow, my computer's running slow. It opened up a window with a circle that is very slowly, because wow, my computer's bogged down. I don't know why my computer is so bogged down. It's very, very slowly pulsating. If my computer wasn't bogged down, that wouldn't be an issue. I think that it may be struggling with me having so many screenshots on my desktop, so let me dump all of those into a folder. Oh, it doesn't want to let me do that. Wow, computer, please don't crash while I'm streaming. Don't do that. Okay, let's see if that speeds anything up. I don't know what else I can close, because wow, that animation is just not doing anything. Looking for windows I can close. We're currently suffering around CosmoQuest what we're referring to as the CosmoQuest curse, which is our computers are systematically one by one across the collaboration crashing and dying. And we don't know, it's just like happenstance. This is, the universe sometimes hates your guts, and the universe currently hates our guts. So I don't know how to speed this up. Okay, let's try this again. Okay, so you can kind of see it getting bigger. And you can kind of see that it's getting whiter as it's getting bigger. Okay, anyways, luckily what I was planning to work on tonight doesn't require this to animate. What I wanted to work on tonight was coding in a layer to create what's called limb darkening. So the first thing I'm going to do is I'm going to get rid of my frame rate, and I'm instead going to put in the command no loop. And what this will do is it will draw the first slide and only the first slide of my animation, and it will stop. And the reason I'm doing it this way is, one, my computer is running really slowly, but it's not dropping frames, so there's that. The other reason that I'm doing this is because limb darkening is something that's going to be very complicated for me to implement, and I'm just going to focus on implementing it with this one particular frame before I generalize that to work for all the different colors. Now, for those of you who don't know what limb darkening is, it's what you see, and let me find an image to exemplify this for you. When you're looking at the sun, you may notice, if you've ever taken really good images of it, that towards the outer edges of the sun, it appears to be a completely different shade. It's significantly darker as you get closer and closer out to the edge of the sun in images like this one. This is actually a picture of the Venus transit from several years ago. Now, the reason that the sun appears to get darker as you get to the edges is because you're actually looking through more and more haze and murk and not looking as much straight down towards the sun. Let me see if I can explain this to you. So I have a handy dandy and currently angry Amazon Alexa right here. She's angry because I have muted her while I'm recording, just so that she doesn't like accidentally pick up her name. Okay, so if I look at the Alexa straight in, there's going to be a whole lot less between me and the surface. Now, if the Alexa was actually a star, there'd be an atmosphere around her. And when I'm looking straight in, I'm not looking through a whole lot of that atmosphere. Now, when I'm looking at the edges, I'm looking through this long cut through this atmosphere that surrounds Alexa. So you can imagine, here's my, and I'm getting double vision trying to look at this. Here's the atmosphere. Here's the sun. If you're looking straight down on this, you're only looking through that one atmosphere. Now, if instead, ignore the finger, I'm trying to figure out how to do this. Okay, I need like one more hand. I know how to do this. There we go. Okay, so looking straight down, I see only through one atmosphere. Now, when I look through the edge, I'm now looking through a larger swath through that atmosphere. And the closer I get to the edge, the more of that atmosphere I have to look through. Now, the more atmosphere I have to look through, the more that atmosphere is going to scatter and block the light of the sun below. So that's the science, essentially. And chat went completely silent. I hope you guys are all still there. So that is the science behind. I'm seeing chat. There we go. Yay. Okay. There's still chat. So that's the science behind limb darkening. I see that some folks are asking, what are the specs on my computer? My computer is, I think it's a 2012. Yeah. I have a 27-inch 2012 iMac. It's pretty zippy. It's a 3.4 gigahertz old Core i7. But I mean, that's the key, is it's old, and sometimes it's just like, no, I won't, just no. So I'm sure I just probably have some window somewhere I haven't seen that isn't working. Okay, so let's get rid of the sun and now try and draw that limb darkening. So right now I just have a really boring, flat, gray box. And in fact, making it worse, I have a flat gray box with a white line around it. So I can't drag it off the edge of my screen. Okay, let me drag it down to the bottom and make this a little smaller. Nah, it's no good. Let me drag this to the side. That's where I can put it. I can put it over here. Okay, there we go. So there is my happy, handy dandy little star that I'm going to find ways to change. So the first thing I'm going to do is I'm going to change this stroke for when it draws the ellipse. I'm going to make it black. There. That was simple. Okay. Icarus, you're making me jealous. So the next thing I want to do is try and figure out, how do I make that gradient that goes in? And I know that eventually my goal is to change the color of this from just flat gray to actually making it a vibrant color, just like an actual star is. Now, the way I'm going to do this is I'm going to start by remembering there is no shame in using documentation. So I'm opening up the documentation and going to the references, and I want to find out how it is that you can adjust the alpha on something. So it looks like I can do a gray color and then just a number after to do my alpha. So I'm going to go ahead and give that a try. And by giving it a try, what I actually mean is I'm going to draw a bunch of concentric circles that get fainter and fainter and fainter eventually. But I'm going to do this in multiple steps. Check everything you're doing as you go, or you will hate yourself later because you'll have a bug and you don't know where it is. And add documentation so that your future self knows you loved it. So I'm never going to remember which color is white or black, so I'm just going to write it in there. Okay, so I'm coming down here, and the fill that I'm using for this this is the stars fill. Okay. Now what I want to do is add on top of that I want to add the limb darkening. Since I want it to be on top, I'm going to literally draw it on top. So the way I'm going to do drawing it on top is I'm going to start just by doing a stroke that is smaller, and it turns out I need to actually do this after I draw it. So I set the colors there, I drew the background. I need to actually like find where the ellipse command is. The ellipse command, that's what sets everything. Okay, so now I'm going to add the alpha layer for limb darkening, and I'm going to do this by doing initially an ellipse that's just smaller. So I'm going to do my radius minus 30 pixels. Whoops, that did not go as planned. There we go. Radius minus 30 pixels. Radius minus 30 pixels. But for this one, I'm going to change my fill color to be 0 is white, 255 is black. So I'm going to do 255, and I'm going to do an alpha value of 0.5, which should be 50%. So if I did this right, the center of the star should have a 50% opacity black circle drawn on top of it. Except I didn't like type out the word radius star. I only typed radius. Let's try that again. That did not go as planned. That did not go as planned at all. Okay. So this is where I need to look up what are legitimate values for alpha, because apparently an alpha of 0.5 was not a thing. So I'm just going to search on the word alpha on this site. and take a look. Alpha values don't go from 0 to 1. They apparently have very different values. So syntax alpha RGB. I'm so confused. I want you to explain exactly what is the range of colors on the alpha, or the range of values on the alpha. Okay. It's assumed it's 100%. Okay, let's look at color and see what color says. So those are all solids. Alpha, float or int relative to current color range. I have no clue what you mean. Okay. It just says add a second value and it'll be used for the alpha transparency. Okay, so let me try adding a 50 and see what happens. Yeah, it's super weird that it is not a value as I would expect. I have no clue what that just did. Okay, so let's try doing 0. See what 0 gets me. 0 did nothing. Okay, valid. Let's see what 255 gets me. It's not giving me any errors. So far it's okay. So that gave me white. So apparently it goes from 0 to 255. And that is deeply confusing. That is very deeply confusing. Experimental programming. Here I come. I don't know. Well, actually, maybe is it 0 to 100 and it's just cool with anything over 100 and it does the same thing? I can't tell. Okay, let's do an even more internal circle and see what we find. Oh, documentation. Documenting, creating good online doc pages is a way you show that you love your community. Why can't I paste? Come on. My computer is being super weird. Okay, I'm just going to type because it's not letting me copy and paste, which is a failure mode I'm not sure I've ever seen before, but we're going to go with this tonight. Okay, so let's see if these are actually the same thing like they looked. Width divided by 2, height. So this is just a reminder that width and height are variables that you get for free. Those are defined when you set up your canvas size, and then you get to use them to do all the craziness you want. And I'm determined to not remember to consistently write the word star there. Okay, let's see what this gets us. Okay, so those are different colors. So clearly this does go from 0 to 255. The more you know. Okay. Sorry that the video froze. Hey Varak3, welcome. I am working on coding a pulsating variable star simulator. Right now I'm working on drawing what's called limb darkening. I think I closed the window I had that shows what limb darkening looks like. Let me open that back up for you guys so that I can remind you of what our goal is. Let's go for a completely different image maybe. Or the exact same image. It's a good image. except I opened the tiny one. That's okay. I can leave the tiny one open in a corner as a reminder. Okay, so what I'm trying to do is add this gradient that you see at the edge of a star. There we go. Add this gradient that you see at the edge of a star to the star that I'm creating in my animation. I don't know if I'll succeed, but I'm going to try. Okay, so now that I've kind of like sort of maybe kind of sort of figured out how this limb darkening works, I could indeed simulate a Tesla car. That would take a lot longer than I'm planning to code for this evening. I'm going to instead just work on drawing limb darkening. Now, currently I wanted to do something big enough that I could see it using an ellipse. What I'd actually like to do is, instead of doing a bunch of nested ellipses, what I'd like to do is just draw a bunch of circles. So what I'm going to do is, instead of having fill equals that, I'm going to do stroke. And then I'm going to do stroke. And I believe that's the color, or no, I think I just did. I'm not sure if that's the color of the stroke or the size of the stroke. So let me look that up on the references as well. I'm trying to figure out, there's where my documentation went. I need to make this window bigger again. I'm trying to find line color. Let's see if that gets me somewhere. So that's how you draw a line. What I want to do is instead set the color of the line. So stroke is indeed how you set the color of the line. So that's what I needed. I don't know how to set the thickness though. So let's look up the reference for stroke and see if it has more information. So I'm going to go back to references. I'm going to search on the word stroke. Stroke weight, that's how I set it. Okay, so I'm going to use a stroke weight of 10 initially, just to make it so that I can see this really well. Stroke weight. This is a bastardized version of Java, so the commands look very Java-like. It's that same camel case habit. Okay, and I'm going to say no fill on these. And this way, it should just be drawing the lines. Now, I don't have to change the stroke weight again because I'd already changed it up above. I do need to add, actually, it still knows to no fill, so I only had to do those two once. Yeah, so this is Java, not JavaScript. JavaScript is really hard. So welcome, Varick3. I'm glad you joined the community. So we can't really see limb darkening in most stars because we can't do angular resolution space cookie. Most stars are like a point source. You can't differentiate any structure on them. But there's a few of the biggest and nearest stars that we are actually able to resolve sunspots and things like that. But we aren't quite to the stage of resolving limb darkening. As far as I know, I could actually be wrong on that. We're starting to be able to do some really amazing things. And hopefully, I will be able to simulate some of them one step at a time. So there are my circles of varying colors. Now I'm going to start putting this into a for loop instead. I'm going to do a stroke of 2. And I want these, actually I'm going to do a stroke of 1. There's no reason to do 2. There's plenty of numbers out there. So I'm going to do a for loop. I'm going to see what variables I've set aside for looping. Currently I don't have any. So I'm going to do variables for loops. This is a language that wants you to declare everything ahead of time. It's tightly typed is the fancy way of saying it. So I'm going to just give it what it wants and tell it these variables are ints. So int for me, please. I'm going to do for I equals 255. So I'm going to start at my highest number. I'm going to do sorry, I'm typing the words I'm saying. While I is less than 0, so 0 means that something's entirely transparent. And each time I'm going to increment I by, I want this to be, let me write this out. So increment I so that the last 30% of the star is limp. So alpha goes from 255 to 0 in n pixels, where n equals 30% of radius. So when I'm incrementing I need to increment it so that in that n pixels, and I'm going to solve for that, int n is equal to radius star times 0.3. So there we go. That's how many pixels I have to do this in. Now I want to actually make this, let's do it like that. That should work. Okay, so I need to now figure out for each of these pixels, how much does the alpha value need to change so that during those pixels I make that whole 255 steps. So that's going to be so I'm starting at 255. So I'm actually prior I value minus 255 divided by n. That's how many steps I need to make on each of these. Now that was a whole lot that I did in one step. There's a good chance things are going to go terribly wrong in a moment. And I need, for each of these, I also need the radius to get only 1 pixel smaller. So this was actually the craziness that tells me how many different values of I am going to do this for. So instead of doing this, there's actually an easier way to do this. Forgive me while I delete and start over. So I'm going to draw circles that get smaller and smaller. And I'm going to go from, and I'm going to do this n times. So I'm going to do this, let's make this easy. I equals 0, I less than n, I plus plus. So the first time I draw a circle, I'm going to draw it with a radius that's the radius of the star. Cool, I'm good with that. The next time I draw it, it's going to be 1 pixel smaller. Then it's going to be 2 pixels smaller. So what I'm doing is I'm drawing a whole series of circles that get smaller and smaller and smaller. Now, as they get smaller and smaller and smaller, I want their color to change. So this is where I have that stroke value that has an opacity, and I set that up here. Now I'm going to instead set it down here, and I'm going to start with 255. So I want this to be a black circle initially. And then I did that backwards. I want this to be black, which is 0, and I want this to get fainter and fainter and fainter every time. And the way it gets fainter and fainter and fainter is I go from an opacity of 255 downwards. And the amount that I'm going down each time is 255 minus however many steps I've taken of 255 divided by n. That was a lot of math. To unpack that, that's what this sentence up here is for. So the first step, I'm going to do the first amount of the first chunk of that 255. The next one is that next chunk. And all of these chunks add up to n chunks. So it's 255 divided by n. I have n chunks. And each time I'm adjusting my alpha value by that much. Now there's a good chance that I'm like going from white to black instead of black to white because I keep screwing that up. It's kind of like the thing I can't get straight in my head. After I'm done doing all of this, let me make sure I turn my fill back on. Yeah, I turned my fill back on right there. Okay. So let's see what happens. Oh, that was fascinating. That was super fascinating and not at all what I intended to do. But it looks cool. I'm getting all sorts of weird vignetting. Okay. So let's maybe not go all the way to black on the edge. Okay, pausing to catch up on the chat. Yeah, I'm programmatically doing the radius. I will go back, Icarus, and do custom functions and stuff later. Right now, I'm just trying to get the basics done. And then I will optimize things as a future step. So yeah, what I did looks super cool and is not at all what I intended. I'm going to make this sucker bigger. So I initially did my radius star is based on 1/4 the width of the canvas. Let's base it on 2.5. So let's make that sucker bigger. Yeah, that sucker just looks cool. I am pleased, but not at the same time. The not being, I don't know why I have a solid white line there. I have no clue where that solid white line came from. Okay, so let's get, oh, it's that. Let me get rid of that. That was not something I meant to do. So I'd left over one of my internal circles earlier. Let's kill that and see what happens now. Okay, so I've kind of gotten limb darkening. The problem is I went from pure black, which was not what I needed to do, down to no darkening at all. So I need RT Robot. Yes, Bob Ross would be happy with this happy little accident. Pleased, probably more than proud. Let me change it. So instead of going from 255 divided by n, let's start at, what's a good shade of gray? Let's try 200. And since I'm typing the same number over and over, I'm going to make it a variable. This is the starting shade of gray, or the starting opacity value. So let's make it an int. Opacity, a nit for initial value, and I'm going to make that 200. So now I just use the variable instead. Opacity init. Okay, good. It stopped being sad at me. This language tells me I have mistakes faster than I can finish typing. So I go through life with it being shouty, and I'm like, I'm not done yet. I'm not done yet. Let me finish. Okay, we're getting better. 200 still maybe a little too abrupt. So let's make this 100. We're getting close. So let's do this over more pixels. Let's do this further into the center. So instead of doing 30% of the star's radius, which is 1/6 of its diameter, let's do that. It's looking a little better. Still not quite what I'd like. Somewhere in between those values is probably better. Let's try starting this at 50 instead and see what I can get. That's looking pretty good. So there's my artificial limb darkening, and let me get a big picture that I can compare with you guys on. Give me a good picture, internets. Internets are being so disappointing at the moment. I want a big picture. There we go. There's a nice large one. Okay, so here is my actual sun, and there is my simulated limb darkening. I am pleased. Hey, Keeper of Maps, good to see you join us. Okay, so I now have a star that has limb darkening, and that pleases me. It pleases me a lot. And so the next thing that I'm going to add is I'm going to see what happens when, instead of filling this with gray, we fill it with a color. Now, the way they do color in processing, and I'm opening my reference back up again, is I believe they set each color with an RGB value. Yeah, so it's RGB alpha. Now, that means I need a table of RGBs. So I'm just going to pull up a standard RGB color picker. And it turns out Google just has one for you. So what color do we want to make our star to start with? That looks pretty good. So now I'm just going to highlight that. And I'm not trying to make the exact same color as the sun. That would be boring. I am instead going to comment out how I have the color changing over time. We'll go back to that. I'm going to temporarily put in a fill of that RGB value. I totally can't copy and paste. My computer is being super weird. 206, 66. Let's try that. There, we've got limb darkening. Now, I did a cheat. Actual limb darkening isn't strictly getting blacker. It's a little bit more complicated. But I'm gonna call this one good for now. Because trying to figure out how to do it all with saturation values is a little trickstery, and more trickstery than I kind of feel like doing. So this is where we are. Now, my goal is, as this thing pulsates, it will slowly change color. And beyond slowly changing color, it will change radius, and it will have limb darkening that stays a constant fraction. Now, that thing that I had just commented out was previously I had my color changing as a function of just shades of gray. So now what I'm going to do is I'm going to have it change from color small is going to be a whiter color. And so I'm going to go ahead and do that as this yellow. And I'll look up more official colors to fill it in with later, but this is where I'm going to start. And then for color large, as the star gets bigger, it gets brighter because there's more surface area, but it also gets redder, and that redder is due to it getting slowly cooler as it expands. That's the basic gas law. If you ever blow a thing of compressed air, the air coming out is cold. That's pressure times volume equals a constant, and it's the perv nerd equation. At number of particles, a constant, and the temperature. And as the volume goes up, the temperature has to go down. Anyways, as it gets larger, let me bring my color picker back. I'm going to have it get redder. So I'm kind of thinking that would be a good color. So I'm going to go with that one. So I'm going to go for my larger to 244, 166. And I'm going to only change this middle color. And so that's going to make this easy, or at least easier. So I'm going to create 3 variables. Int is my red value for my red, green, blue. And I'm going to give that a value of 244. I'm going to create an int. I'm going to call that one green. This is the color that's going to be changing. But it's going to start at 206. Let's start with a little tiny star that decides to expand. And I'm going to have one that's called blue. This is going to be value of 66. And I'm just going to line this up to make it a little bit easier to read. So as it pulsates, change the blue value from 206 to 166. Now I was using a sine function to kind of base everything off of. Now my sine function is going to cause the star to get bigger and then get smaller and then go back to its normal position. So I actually can't just start at 206, so I'm going to actually start at the middle value. That middle value is 206 minus 166 divided by 2. So that tells me my starting value for the green. Now, as this changes, what I actually need here is my delta color. This is how much my color is going to change. Int equals delta color. Let's make this look like a variable. Boyle 83. You guys are doing math for me. Space Cookie, I have got to go set up a GitHub for this stuff, and yes, it will be happening. Okay, so the delta in color is going to be 206 minus 166. So that's my full range. So green is going to start at my bottom value, which is, okay, and now I'm going to do int, let's actually, comments. I shall write comments, 206. This is my max green value. Okay. Minus, now I'm just going to add the word green max. Okay. Okay, let's start there. As it pulsates, change the blue value from midpoint to 206 to 166 to midpoint. So the reason that I phrased it that way is I'm doing this as a sine curve. And my sine curve is based on time. It starts at 0. So I can do not my blue value, change the green value. So my green over time is going to be equal to, my starting value is green max minus delta color divided by 2. So that's my starting point. Now I'm going to add to this. Now remember, my sine wave is going to go from 0 to +1 to -1. Sine is convenient that way. So I want it to go from, I'm only going to ever need to use this value divided by 2. So I'm going to have it go as delta color times sine of, and here I have the information up here from when I did it before. I'm just going to copy and paste it and see if my computer will let me do that this time. My computer still won't let me copy and paste. This is a failure mode in my computer I have never seen, and it's a little bit scary. I'm just going to let you know that. So time divided by period times the internal variable that I don't ever have to worry about declaring. Yes, that all looks completely reasonable. Okay, so I have my color change value is set. My fill value for this is going to be red, green, blue. Okay, that's all good. And I'm going to put my frame rate back. I'm going to apologize in advance that my computer is being a hateful creature and is going to do this extraordinarily slowly. And theoretically, this should give me back my pulsating star, and it should have limb darkening. Cannot convert from float to int. Okay, so what do I have that is a... Okay, when all else fails, stick everything in a set of boxes. There we go. Aha! So you can see it's getting bigger. It's getting yellower as it gets bigger. I might have done that backwards. It's now starting to get smaller. It's getting redder as it gets smaller. Yeah, I totally did my colors backwards. So I need to reverse the signs on my colors. Okay, that's okay. I know how to do that. Okay, let's try this again. And now it should get redder as it gets bigger. There we go. See, you can see it very slowly increasing in size and getting redder as it gets bigger. And it has the limb darkening. Now it's contemplating. There it goes, getting smaller again. Getting yellower as it gets smaller. So now we have a pulsating star that changes colors and changes radius, just like a real star does. Now, while it's behaving in general like a real star, I don't have all the details of the science precisely right. And one of the other things I want to do is add to this a plot of brightness over time so you can follow along with what's going on. And that's what I'm going to be here doing next week. I am going to work on trying to put together a GitHub so you can download my code and follow along at home. And together, hopefully, we can make a really cool educational simulation. So for those who joined late and have no clue what insanity you encountered, my name is still Dr. Pamela Gay. It's kind of written below my face. And I have been writing software to simulate pulsating variable stars using processing, which is a mutant version of the processing computer, mutant version of the Java programming language. When I'm not on here coding like this, I am the principal investigator of the CosmoQuest project at CosmoQuest.org, where we invite you to come learn and do science. We have a whole variety of different projects that let you help us and help teams of NASA scientists map out the surfaces of other worlds. So come join in and learn some science and help us map out our solar system. So I will be back same time, same place next Tuesday night. And in the interim, you can join in as Matt Richardson, our project postdoc who works for the Planetary Science Institute. He will be here on Wednesday and Friday. And I believe that Big J, Joe Meyer, will be here next Monday night teaching the processing language. We are a multi-institutional, I see you calling us a nerd channel. We are a nerd collaboration. And we are here to teach you all the wonderful nerdy little things. This is a project that is run out of the Astronomical Society of the Pacific. And we hope you'll join along and that we'll see you more in the future. So thank you and have a wonderful evening, afternoon, morning, whatever it may be, wherever you are in the world. Thank you. I'll talk to you all later. Bye-bye.